Hello, welcome everyone. Today we are going to discuss some numerical problems on vectors from simple just advanced level. So let us start with A, B is given uh, A vector equal to I cap plus 3j cap, B vector equal to 2I cap plus 4j cap, and C vector equal to I cap minus j cap. A vectors and B vectors and C vectors. Find the components of vector A plus B along x-axis and y-axis. So first of all we need to calculate A plus B. So let us start. A vector plus B vector equal to I cap plus 3j cap plus 2I cap plus 4j cap. So I cap will be added with I cap 3I cap plus 3, 4, 7j cap. So this is A vector plus B vector, and component of this along x-axis, this is the component along x-axis 3. So Roman 1 will be 3, and component of y along component of A plus B along y-axis. So this is the component of A plus B along y-axis, which is the coefficient of j. So similarly with the coefficient of k will be component of along z-axis. So component of z-axis along 0. So this is for 2 along y-axis. Along y-axis will be 7. So you can understand about this. And also along C vector. So along C we have already discussed that to find the component along C, so we will be dot product with C cap. So it will be A vector plus B vector dot C cap. Then we get the component along C. So will be 3I cap plus 7j cap plus dot C cap means C vector divided by mod of C. So 3I cap plus 7j cap in C vector I cap minus j cap divided by root 1 plus 1. So we get there is the dot product. So we get 1 by root 2, this is be root 2, and we get 3I cap plus 7j cap dot I vector minus j vector. So 1 by root 2, 3 dot 3 I dot I 1, 3 plus 7 minus 1 will be minus 7. So we get 1 by root 2 to minus 4, or minus 4 divided by root 2, or 2 root 2. This will be minus. So this is the component along C vector. So now problem number 2. Here if A vector 2I cap minus 3j cap plus 7k cap and B vector and C vector, find A dot B cross C. So how can we get this? A vector equal to 2I cap minus 3j cap plus 7k, B vector equal to 3I cap plus 2j cap, and C vector equal to j cap plus 3k cap. So get A vector dot B cross C equal to, this can be written as, first of all the component of A will be written as 2 minus 3 and 7. 2 minus 3 and 7, I, j and k are component, and then B component of B, component 3, 2, and with k there is a 0, so 0, and C component with I there is 0, so it will be 0 first, and j component of j 1 and component of k 3. So find the determinant, will get A dot B cross C. This is also called vector scalar triple product, as it is a scalar quantity, so it is called scalar triple product. So how can we get this? 2, first of all 2, this 2 will be written as that, and skip this part, remaining this will be 2, 0, 1, 3, and then the second will be negative, first positive then negative, and then it will be minus 3, then minus 3, and this will be skip this part, and the remaining 3003 will be there, 3003, and plus minus, then plus 7, and for 7 this will be skipped along 7, and the remaining part will be 3, 2, and 0, 1. So we get calculated from this, we'll get 3 into 2, 6 minus 0, and plus 3, 9, plus 7, 3 minus 0. We get 12 plus, and 3 into 9, 27 plus 21, and sum of this will get the result. This is called also scalar triple product. Now the next problem, here find the unit vectors perpendicular to a vector and b vector both. To find the perpendicular to a vector, b vector, just cross product of two vector. We know the cross product a vector and b vector, their cross product will be perpendicular to the a and b. So find the unit vector along this direction is the cross product of two vector, unit vector of a cross b. So how can we get this unit vector n cap equal to a vector cross b vector divided by mod of a cross b. So here given a vector equal to 2i cap plus 3j and k cap. So b vector equal to I cap minus j cap plus k cap. So how to get a cross b? We know by determinant. A cross b equal to I j k, and component of I 2, and component of j 3, and component of k 1, and component of I of b 1, component of j equal to minus 1, and component of k 2, all discussed in our previous lecture. So we get from this determinant we get 3 1 minus 1 1, and minus j with 2 1 1 1, and plus k will be 2 3 1 minus 1. So we get 3 plus 1 minus j 2 minus 1 plus k minus 2 minus 3. So this is the a cross b, 4i cap minus j cap and minus 5k cap. So determinant of here for unit vector, find the determinant mod of a cross b into root 4 square plus 1 square plus minus 5 square equal to root 16 plus 1 plus 25 equal to root, here we get 2 and 4, 42. Vector will be n cap equal to 4 I cap minus j cap minus k 5 k cap. This formula root 42. So this is the unit vector both perpendicular to a vector and b vector. Now in the next problem, show that the vector A is parallel to vector B. So two vectors are parallel, that means the angle between them 0. So there are two processes. One is to find the angle theta equal to 0 by a vector cross b vector equal to 0. So if the cross product of a cross b equal to 0, means a cross b equal to, we know, a b sin theta into n cap. So if their angle is 0 and sin theta is 0, that becomes 0. So this is the one process, the first process, and the second process is the both are parallel. So there is a linearity and there is a multiplication factor such that either A equal to m into b vector, because the length is just a number. So if they are both parallel, so one length will be some multiplication of the other, and this is both condition for parallel to vector. We get a vector equal to I cap minus j cap plus 2 k cap, and b vector equal to 3 I cap minus 3 j cap plus 6 k cap. So by common we get 3 common, and I cap minus j cap plus 2 k cap. So I cap minus j cap plus 2 k cap equal to the a vector. So we can write b vector equal to 3 of a vector, which is the same as here we get p vector equal to 1 by m into a vector. So this is just a scalar multiplication factor. We get scalar multiplication factor, so we can write that a and b are parallel. Here the next problem is find the resultant of three vectors. Here given the OA, OB and OC. So let us see OA, OB and OC. And suppose along the direction x-axis, then perpendicular to y axis. This is 45 degree and this is 90 degree. So to find the resultant of all these three vectors, suppose this is f1 vector, this is f2 vector, and this is f3. OA equal to f1, OB equal to f2, and OC equal to f3. So we know f vector equal to resultant vector f equal to fx I cap plus fy j cap. So fx, the component of x component of all f1, f2, f3. So how can we get this? Fx equal to f1 cos theta 1, f2 cos theta 2, f3 cos theta 3. So we need to calculate theta 1, theta 2 and theta 3. Theta 1 is the angle between f1 and x-axis. Here f1 is along this x-axis. So theta 1 equal to 0 degree and f2 is 45 degree angle with x-axis. So theta 2 equal to 45 degree and f3 is along y-axis. So theta 3 equal to 90 degree. Okay, then just substituting we get all this length OAOBC equal to r, radius. So we can write all this length equal to r cos 0 degree plus r cos 45 degree plus r cos 90 degree. So by this way we can calculate fx equal to r plus r divided by root 2, and this is 0. Similarly, fy equal to f1 sin theta 1 plus f2 sin theta 2 plus f3 sin theta 3. So you can write f1 r sin 0 degree and r sin 45 degree plus r sin 90 degree. So this is 0 and this is 1. So we get r divided by root 2 plus r. So by this way we get fx, fy. So f vector equal to fx I cap plus fy j cap. And also we can calculate magnitude of f, root fx square plus fy square. Also we can write the f vector makes an angle x-axis if there is additional question. So if f vector along this direction which makes an angle theta, so this will be fx and this is fy. So you can write tan theta equal to fy divided by fx. So we also know fx and fy. Just substituting this below, we get equal to 1. These two are equal, fx and fy 1. Then theta equal to 45 degree. Okay, by this way we can also calculate numbers of resultant vector and numbers of vectors. Now in the next problem, the angles which the vector a 3i cap plus 6j cap plus 2k cap makes with the coordinate axis are. That means the coordinate axis x, y and z. Suppose this vector a vector. So angle makes with x-axis alpha 1, angle makes with y-axis beta alpha, makes beta, and angle makes with z-axis gamma. So this can be written as, we know, a vector equal to x I cap plus y j cap plus z k cap, where x component of x, a vector along x-axis, this is also written as a cos alpha, and a y, the component of y along y-axis, component of a along y-axis, this can be written as a cos beta, and a z, the component of a along z-axis, that can be written as a cos gamma. So from it we get cos alpha equal to a x divided by a, cos beta y divided by y, and cos gamma z divided by a. Whereas the magnitude, so first of all we need to calculate magnitude a, and then ax divided by you get cos alpha. So from this equation we get a vector equal to 3 I cap plus 6 j cap plus 2 k cap. So mod of a equal to root 9 plus 36 plus 4 equal to 7. So we get cos alpha equal to ax divided by a. X means this is 3, the component of a along x-axis, 3 divided by 7, and we get alpha equal to cos inverse 3 divided by 7. Similarly, cos beta 6 divided by 7, but beta equal to cos inverse 6 divided by 7. Similarly, gamma equal to cos inverse 2 divided by 7. So option A is correct. Okay. Now in the next problems, here the three vectors satisfy the relation a dot b equal to 0 and a dot c equal to 0, then a is parallel or antiparallel to these four options. So first of all, there is given a vector dot b vector equal to 0 and a vector dot c vector equal to 0. So dot product, from dot product formula we get a vector dot b vector equal to ab cos theta, where theta is the angle between a and b. And similarly, here from a vector set dot c vector equal to ac cos alpha, where alpha is the angle between ac. As these are 0, then cos alpha will be 0 because a and c cannot be equal to 0. So if cos alpha equal to 0, then alpha equal to 90 degree. And also from this relation we get cos theta equal to 0, as a and b cannot be equal to 0. So we get from this relation theta equal to 90 degree. That means a and b both are perpendicular. Also a, c are both are perpendicular. That means a, b and c perpendicular to both a, b and c. That first option, a is parallel or antiparallel to c, then first option a is not parallel or antiparallel to c, because a, b, c, a is perpendicular to c, so first option is cancelled. And b is also a is perpendicular to b, so a is not parallel. That means parallel means along a, and antiparallel means along opposite of a vector. So b, option B also not correct. Here both a, b and c, all these are mutually perpendicular to each other. So b cross c means cross product of b cross c. There is a unit vector perpendicular to both b and c, perpendicular to this plane. This is b and c plane. So perpendicular to this plane, either a along this direction or antiparallel to a. So option b cross c will be correct. B cross c, this will be correct. And also b dot c, which is scalar quantity, not vector quantity. So option D also incorrect. Here in next problem, in the diagram shown in figure, where the option given as vector b vector along this direction will be minus b vector, and minus c means c vector along this direction. So minus c vector will be along this direction, c vector. This direction c vector, to this direction will be minus c. So to find the x vector, we need to sum a vector plus b vector plus c vector plus d vector. So this direction will be along. So we can write from x vector equal to a vector along this direction, plus along this direction will be minus b vector, and along this direction will be minus c vector, and along this direction plus d vector. So this is the correct form of x vector, but they give incorrect, so the option A will be incorrect. And now option B, y vector. So how to find the y vector? Y vector equal to along this direction y vector. So this will be equal to c vector plus b vector plus a vector. That means the path you straightly coming from O to, suppose this P point, so this is y vector. So y vector equal to, along this direction will be sum of c plus b plus a. So arrow sign will be along this direction, arrow sign. So along this direction c plus b, but a vector along this direction, so this direction will be minus a vector. So it will be minus a vector, but this is the incorrect, but they give the incorrect result. So these are minus a vector. This is the correct value of y, but they give incorrect. So option B also incorrect. And z, so how to find the z here? The z, this is the z vector. Z vector 0 to along suppose q. So from 0 to q, z will be sum of 0 to this c vector plus b vector. So you can write c vector plus b vector. So this is the correct form of j, which is given c is a correct option. And for D, w vector equal to w vector along this direction, it will be a vector, and this is the in this direction minus b vector. So do a vector minus b vector. This is the correct form of w, but they give incorrect. So this is wrong option. Now in the next problem, find the resultant of three vectors shown in figure. Suppose this vector equal to f1, this is f2, and this is f3. So same as component wise, theta 1 equal to f1 makes an angle theta 1 with the x-axis, and f2 parallel to x-axis. So theta 2 will be 0 degree, and f3 along the y-axis. So theta 3 equal to 90 degree. So you can find the resultant vector. F vector equal to fx I cap plus fy j cap. So fx equal to f1 means 5 cos 37 degree plus f2 3 cos 0 degree plus f3 2 cos 90 degree. So we get 5 into cos 37 degree, which is approximately equal to 0.8, plus this is 3 1 and cos 90 degree 0. So from this equation we get 7, and fy equal to, that cos will be sine 5 sine 37 degree plus 3 sine 0 degree plus 2 sine 90 degree. So 90 degree will be 1, and this is 0, and 5 into sine 37 equal to approximately 0.6 plus 2. So we get 5 into 0.6, 3 plus 2 equal to 5. So we get fx and fy. So resultant vector f vector equal to written as fx I cap plus fy j cap equal to 7 I cap plus 5 j cap. So this is the resultant vector, and magnitude f vector mod equal to root 7 square plus 5 square. We get by this.